Hi guys, welcome to another video. So in this video I wanted to talk about geometric series and understanding the formula for summation with geometric series. I'm just going to go over a few basic concepts and ideas relating to this, and hopefully understanding where the summation formula for geometric series comes from will kind of help you understand a little bit better why you're using it. Because quite often you can just get caught up in the fact that you keep using this formula over and over on tests and exams without really understanding why it is the way that it is and why it's specifically that exact formula. And 99% of the time, the reason why you're using a specific formula isn't just because of convention, but it's because of a set of logical rules. And I feel like understanding where they come from and really seeing how these ideas come together, first of all, adds a lot of depth and beauty to what you're studying, and it gives you context as to why you're doing what you're doing. And second of all, it really helps cement your understanding, even to the point where you won't need to be looking in the formula sheet and trying to recall what you need to know, because you'll just already intuitively understand this and be able to recall it faster on the exam. Okay, so just a reminder before we get into the summation formula, what is a geometric series? A geometric series is any kind of series which has consecutive terms which differ by a constant ratio. So let's look at an example. A simple example of a geometric series. Let's say our first term is 2. And we're going to have a ratio of 2. And that means that our second term will be 4. Our third term will be 8. And our fourth term will be 16. Now, why is that the case? If you'll notice, every single term I'm multiplying 2 by this ratio raised to a certain power. So 4, I can rewrite that as 2 to the power 2 times 2 to the power of 1. This is 2 times 2 to the power of 2, since it's 2 times 4. And this is 2 times 2 to the power of 3, since 2 to the power of 3 is 8. So if you'll notice, there's always a relationship between the position of the term and the exponent of the ratio. And a general kind of way of understanding this is an nth term of a geometric series is always expressed as un is equal to u1 multiplied by r to the power of n minus 1. And the reason why we do that is a bit similar to arithmetic series. If you think about it in an arithmetic series, what we do is we take the first term and we add a difference n minus 1 times. Whereas here, instead of adding a difference, we're going to be multiplying the first term by some ratio. If the ratio is, the absolute value of the ratio is less than 1, that's an infinite series, but that's going to be another video. But okay, let's see why we use the formula that we do use. Okay, now let's say that we have some sort of geometric series. We're just going to write it as a1 plus a1r plus a1r squared plus a1r cubed plus whatever a1r to the power of n minus 1, right? And we're going until the nth term, okay? And we're just going to denote this as s. Now I'm going to take another color. Now, what we want to try and do, usually when we sum together a bunch of terms, is to somehow get them to cancel and get them to come together in a single nice kind of package. And you actually see that quite often with induction techniques. So what can we do to cancel out all these terms? Well, obviously we can't just start randomly subtracting terms. However, what we can do is if we multiply this entire sum by the same ratio, then we're going to be able to almost replicate all of the terms. in the series, and then if we subtract them, then we might be able to get something. So let's see what that gives us. We're going to take the same sum, s, except now I'm going to multiply by r. So what does that give us? That gives me a1r plus a1r squared. And keep in mind, all I'm doing is I'm taking each term and I'm multiplying it by the ratio r, plus a1r cubed plus a1r to the power 4, and that's going to continue until a1 to the power of r n minus 1 plus a1 rn. Okay, now this is actually quite useful because if we subtract s, hold on. If we try to cancel out these terms by subtracting rs from s, so if we do s minus sr, then look, this term and this term are going to cancel. This term and this term are also going to cancel. This term and this term are going to cancel, and every single term is going to cancel, except this last term, the a1rn, and the first a1, right? Okay, so we're going to get s minus sr is equal to a1 minus a1 rn. Okay, great. Now let's see if we can factor out the sum, because essentially what we're trying to do is get a formula for the sum. So we factor out the s. Since here we have s minus sr, we can factor that out. We write this as s times 1 minus r, which is equal to a1 minus a1r to the power of n. And note that we can also factor out the a1 on this part, so we're going to go ahead and do that. And that gives us the formula which we have been trying to find. So hopefully that should look familiar, and I hope that gave you a bit of insight as to where this stuff comes from and why this actually does make sense and it's not just a random formula. Thanks for watching.